welcome to Highway Academy. In this video, we're going to look at generating a speed profile in Civil 3D and Civil Designer. Start to finish. Good morning everyone and welcome to Highway Academy. Today we are going to be looking at something we call climbing or crawler lane analysis and design considerations. So as you know, on most of our highways, some of the times because the heavy good vehicles, you can have most cases steep gradients or areas where you need a lane to allow for the heavy vehicles to kind of move while keeping a higher level of service. So what is a climbing or a crawler lane? What are the considerations that we take? So climbing is, I think, UK, crawler lane is the US. So climbing lanes are introduced on high-speed grades to provide for trucks and other vehicles whose speed drop because of a grade. So there are areas whereby you find that as a result of these heavy vehicles, there's a drop in their speed as a result of the grade. Now, normally, most of the manuals you find around, AASHTO and all the others, they're going to recommend if a climbing lane is necessary, if you find that there's a speed reduction of 15 to 20 kilometers per hour. So let's say you have a design or operational speed of, let's use 80. And if you drop to 60 or 65 kilometers per hour, it now means let's have a look at a situation where we introduce a climbing lane. But then there are a number of conditions. One, if you find that the whole flow exceeds 20 vehicles per hour, let's say in the future when you forecast, then there's a need for a climbing lane. And this can come to X given amount of vehicles per day. Most of the manuals state these vehicles per day. But if your flow per hour exceeds 200 vehicles, and of that, the future flow, you find that there are 20 heavy vehicles per hour, then that's guaranteed. So find if you have these three conditions, it's an obvious. You have to have a consideration of a climbing or a crawler lane. Now, what are normally the considerations? The image below shows a typical climbing lane, the consideration you take. So you find that sometimes the lane width is normally 3.25 to 3.5 meters. And it's always very good to ensure that your climbing lane ends 60 meters before a crest. Okay. Now, what are the safety considerations? You'll find that some of the times here, what I'm showing you is in blue, we have the normal lane. Okay. And then here we have something like an overtaking lane. Okay, with kind of like a median. Okay, and the beauty with this kind of median is it prevents oncoming traffic from using the climbing lane. So there are situations where you have a climbing lane or a passing lane and you find that there's no median. So this traffic in the opposite directions tends to want to use this climbing lane to overtake and then go back in the other direction, which is something normally that's very, very dangerous. And I think this design is good for a climbing lane because what happens is you leave the heavy vehicles to continue on the existing lane while the other vehicles can overtake the heavy vehicles. Rather than making the heavy vehicles make a deliberate decision to turn to the climbing lane, I kind of prefer this compared to this because now here's the original. What normally the climbing lanes we've been doing is the heavy vehicles have to go into the climbing lane while the normal vehicles remain. But because I'm moving at a slower speed, I think it's much better if the heavy vehicles continue and then the vehicles that really need to overtake are the ones now overtaking. Okay, so it's something in that case. I feel this design has a number of issues, especially in some of the developed countries where the vehicles may not be in the very good state. So it will be easier if we keep those vehicles on the same lane and then you have a passing lane. So to analyze this, we have to look at something called a speed profile. And in short, a speed profile is just a plot of speed against distance. Now what you're seeing in the right is just a plot of the speed. So here we have kilometers per hour, and then we have a distance. Let's say the chain edges in meters. So, and what we are trying to see is, okay, if a vehicle is moving, is it going to drop below 20 kilometers per hour? So, for example, if here we're starting at 50 kilometers per hour, is it dropping to 30? And if it drops 30, what's that change at which? That's where we take a consideration for a climbing lane. So then we find that there are two ways of generating speed profiles. One's using a table and one is using a road design program, which allows for speed analysis. Okay, so now the normal method is to look for a speed profile using a table. So you find most of the manuals will have some form of example and an explanation. And this video, I'm going to just try to go briefly into this table method, and then we shall use a 3D program. So if you're interested in looking at how to do it using a 3D program, which I recommend because you have more control, I recommend that you look at a later part of this video. So here I'm going to just give an example. So we've been told, one, to calculate the speed profile for heavy truck, which has a power mass ratio of 5, and it starts at a speed of 80 kilometers per hour. And then after that, it follows a profile of 6%. So you start with this, then you go to 6%, and that's followed by a straight, and then a 500 meter sag. So a 500 meter sag, preceded by a 7,000 meter crest and a 2% grade downhill. So we have a 6%, then a 2%. Okay, then we have a crest at this point. So you know here at the 6% we have to analyze the need for a climbing lane, and we have to look at how the speed drops. So we come up with a number of points. We come up with 0.1, 0.2, 0.3, 0.4. So what happens at 0.1, the length is 150 meters. After that, it rises for 1,000 meters. We're now looking at the PVIs. Then this goes for 300 meters, then this continues. Now, what you'll find is this is 150, and for this case, that's why we're having the 0 grade. Then you have a 6% grade. And then for another distance of 1,150, that's the area we're talking about where you have the 6%. And then after that, because it's a summation, a continuation, so you get this, you get the 150 plus the 1,000. That's why you get this, then this, and that, because it's a continuation, like an extension. So now you have charts like this. These are charts that you find in standard manuals, where you have the length, you have the grades uphill, then you have the grades downhill. And we're trying to look at a case of uphill. So we're going to have a huge focus here at the beginning. And so we're going to look at how we transition from A to B to C to D to E to F. So remember the track we talked about. The track will be affected from the start, let's say with 0.2. This element is 1,000 with a 6% grade. Now, the first thing we are looking at is we have a case of 6% grade, okay? And that's at a distance we highlighted earlier, at a distance of 1,150. So you're going to find that if we are starting, for example, they told us that the start speed is 80 kilometers per hour, okay? So we are going to start at 8 kilometers per hour, okay? And the one thing we're going to look at is we're going to look at the 6%. So we have 8 kilometers per hour. And what you're looking at here are these profiles for the different grades. So we have for the 6% here. So it goes up and then curves all the way to the top. So if we start with 80, our point A is going to be there. So this is where we're starting. We're starting at 8 kilometers per hour. Okay. In that case, then we do this and that's at the start of 150 here. Okay. Around here, because this is 1, 2, 3, 4, 5. So each of these is 100. Okay, so the first 150, we draw a line going up here, which creates point A. So point A starts along here. Now we're going to go 1,150. Okay, so the next point B is here. Now to look at point B, we look at 1,150 going up, and then we're looking at 6% grade. Now, when you draw back the line, we're going to find that the track falls to 30 kilometers per hour, okay? And now we're going to point C. Remember what we talked about point C? Okay, so point C, what's going to happen? because we've come from a 6%, okay? And now what we have done is we have traveled a gradient of 6% to point B, which has lowered our speed to 30 kilometers per hour. Okay, and now what's going to happen is we're going to a point of 0 grade. So we're going to look at the 0 grade here, and we see how it meets with 30. That's how it meets at point C, okay? Because we have a 0% grade at that point. And that's how we come to point C, okay? Now, again at point C, we move another distance. Now, if you remember here, that's why it's very important to look at this distance. We'll move a distance of 310 meters. Okay, so we move 1, 2, 3, 310. You look back up here, and that's point D. You look at point D, the track has gone to roughly around maybe 56 kilometers per hour, okay? And that's how it's reaching point D. Now, when we reach point D, again, we're going to look at the grade. We go back to a grade of, now we are going downhill, okay? Which is a 2%, okay? Which is a minus 2%. So now we're going to look at downhill, minus 2%, and that's how we end up coming back to point E. And then furtherwards, we're going to point F because we go another distance of 100. And this is how the track gains back to the 80 kilometers per hour. So if you do that, draw that graph properly and lay it out really well, this is what you're going to end up as your speed profile. As we say, the car moves for 110 meters to point A. Okay, then that speed drops for the 1000 meters that we talked about, okay, to a speed of roughly 30, in this case 28 kilometers per hour, drops to 30, then afterwards drops to 28, then afterwards raises back again to around 56 kilometers, then comes back. So because we said if you drop 20 kilometers per hour less, so we know from the start here around 350 to around, well, maybe roughly around 1,500, we need to have a climbing lane. And this is how you do it with the table. Now, the problem with this is you have to look at the different, all the different grades where you have this and draw these speed profile curves. And then the challenge I have with these graphs is you don't know what they've estimated for the power ratio for the vehicles. So we have areas where we know most of the vehicles in that area will not be as powerful as assumed here, or the other areas where you find all the vehicles will be way more powerful. So I tend to use this just as a confirmation, but normally I prefer to use the program, okay? Now in your country it could be a bit different, but the concept is the same. So what's our workflow here? Our workflow is one, we move from Civil 3D and we use a program called Civil Designer. So what we do, we have to get the design profile land XML that has no ground, and also we get a ground surface in a land XML that has a ground. And then after that, we export out this information, put it in Civil Designer, we generate road edge levels, then we generate a speed profile diagram, and then we come back to Civil 3D and draw it, okay? So how do we use a speed profile? How do we generate a speed profile using a program like Civil Designer? Okay, so normally there are a number of parameters that we need to know in Civil Designer. Okay, the first is the start and end chainage with the basis on the speed. So here you agree that, okay, if my speed has multiple speeds, split it up. So for example, maybe from 0 to 5 plus 600 is 50 kilometers per hour, then from 5 plus 600, 70 kilometers per hour. Split it up in that way. Okay, you need the initial speed, just like highlighted in the previous example, maybe that's 80 kilometers per hour. You need design speed of the vehicle, the areas where you have operating speed, but normally these are assumed they are the same, but if you're in a situation where they're different, record it different. So then we have the frontal area for your vehicle. What is it in square meters? This normally I leave to the default. Then you have the weight in tons. Now this varies based on your surveys. You must have done some surveys and you make some assumptions. So in this case, we're going to try and use 44 tons. Then we'll go look at the power. Now this is very important. They normally ask for the power in kilowatts. Now this is my own research, and what I found out was the Green Book assumes for the cases, the power for trailers used on intercity highways is normally between 205 kilowatts. That's 275 horsepower, and then 485, which is around 685 horsepower. So these are the two values which I vary by, and this is why I said I normally it would be good to do surveys for this, okay? And I know I think they try to average this out a bit, but the beauty is when you have a survey done in your area in regards to the power of most of the vehicles that are moving there, you can estimate a good speed profile. You don't want to come up with a speed profile where you find that, oh, in the climbing line, I have assumed most of the vehicles maybe are 485 power kilowatt, and then you find that the climbing lane there's no value for money, okay? But we're going to design for the worst case scenario of 205 kilowatts for this example that we're doing. So let's proceed. So I'm going to open up a drawing showing how we do this analysis. Okay, so now we're in Civil 3D. I have a drawing called Speed Profile Demo, and we just have a road that's moving and it's going all the way. And this is like your standard design. You have everything else. And what you're going to find here is what I've done is it has a number of, it has a profile, and this profile has both the ground and the design. What my main interest is in this case is to export out only the design profile. Okay, so you have two. So this is our design. As you can see, this one is the ground. So the first thing we're going to do is we're going to export out the design. So I go to output, click export land XML, and untick everything, and then select the design profile, which is this. Okay, this is our design profile, and we're going to export it out. And the place where we're exporting it is, we're just putting it in the place where we have a demo speed profile. So I'm going to name this demo speed profile, okay? Export. Then the other thing you do is you export the ground, okay? So I'm going to export the ground, and I'm going to name this demo speed profile EG. So we finish exporting out the ground, and this is the information we shall need to produce most of the information in Civil Designer. So now you open up Civil Designer, okay? And now what you're going to do is you're going to create, you're going to go to you're going to click here and click survey, okay? So click applications, click survey, and then you have something called project settings. Do something called terrain, tick this, and then we're going to name this the ground, okay? So normally you have nothing there, so we're going to name this ground speed profile. Okay, so it has this weird command of when you click open, it's going to be like the file doesn't exist, so you're like create the file, and then you're like yes. Then do your coordinate system. My coordinate system is this, and I'm in UTM, and I'm going to use Clark 86, and I'm going to use 36N. Okay, and then I'll click OK, and I'll set this as the default because most of my projects are here. So now we're going to try and import in the ground. So you click File, Import, Land XML, and in this case we're going to import the EG, and the software is going to try and do its magic. It's going to show you here, this is the ground you're importing in, and then you bring it in. And it's going to ask you, oh, there's the data ranges, and you're like, that's fine with me. I'll click OK. So the bar runs here showing you how to import in everything, and it's reading all the points. It's quite a large surface, but this should be okay. So you can see it has exported the surface, it has imported in the surface. So now we click applications and then change it to roads, okay? And then you click file, import, land XML. So now go and bring in the road, which is the speed profile. And then it's going to tell you, okay, that's our road. Click OK. And it's going to say there's maybe a mini curve overlap, the two curve overlaps, which I'm okay. I'm like import that in. And it's importing in all the road data, all the vertical road data, okay? Now, when you can, the purpose of this video is not to show you how to use Civil Designer, because it's just like any other road program. You have a number of things that you have to consider in regards to super elevation and all that. So I'm going to make an assumption to assume you have an idea on how to use that. Okay, so we zoom in to where we have the road so we can see the chainage. Okay, so what you're seeing here is our road, the straight line. So you have to select it. This part is very important. You have to select the road. And now there's along the alignment, there's something we call, there's the horizontal. You can edit it in case you want, do a number of things. There's the vertical. This I've already done in Civil 3D. And there's editing the super elevation, lane widening, if you want to look at all those things. But I'm not going to go into that. The vertical taper, you can extract this from CAD. You have the regression and all that. So you have something called the road expert, okay? And road recalculate settings. So normally we first look at this and we're like, what do you want it to do? We want to extract the ground cross sections, generate the vertical alignment, generate the road elevation level, apply the road template, okay? So it can extract all this, which is fine with us. So you go here, you click road expert, and it's going to tell you, okay, what do we want to do in the road expert? There's extracting the ground cross sections, edit vertical alignment, generate vertical alignment labels, edit super elevation, generate road, and apply the road template, which is something we want. So we click OK, and it starts to generate. As you can see, it's extracting along the chainage. Now we're on chainage. We are now maybe 20 kilometers in. Okay, so it's extracting everything, and it's going to look at all the different facets, and it's going to add a road template. Of course, with the magical power editing, I'll show you once this is done. I'm not going to take you through all this. So now we're on chainage 67, and it's extracting all the ground cross sections, and it's going to apply the road template. Okay. So we've come to the end. So it's now calculating the levels for the whole road based on the vertical profile, okay, for the area, for the road. And maybe I didn't take you through the profile, just to show you areas we suspect that are, but we can see here, we can run it and then we see. And it's going to ask me, what kind of, do you want a camber full, camber crossfall full? Normally I go for this because we come from this and then we lose it. And then we transition based on the analysis you want. Click OK. And that's going to draw the road plan, okay? It has drawn the road plan. So we select the alignment again. Then we select, so notice we've selected the alignment, we've selected speed profile. Now I want to do this up to chainage 66, and I'm going to show my initial speed is maybe 70, and the allowable speed reduction is 70, and this is 70. We talked about this, and this is roughly 205. Okay, so we drive on the left-hand side. If you drive on the right-hand side, select that. Now this left and right means you're going to analyze in going from the start to the end, and then the right means you start from the end to the start. Okay, it's in the reverse. So when you click next, it's going to analyze and say, okay, where do we need a speed? Where do we anticipate that we may need a speed profile in this case? So if your starting speed is 70, it's trying to tell us the change between 44, 500 and 45. This is a distance of roughly around 500 meters. We need some form of climbing length. Now, why is this very important? So let's say you put 80 here and you have 80. No, I don't. Speed profile 80, 80 that. So click OK. So you see, as your design speed goes higher, the impact is much higher, okay? So this project, I think, which we did, we had a 90 kilometers per hour, and we are showing the same. And we are looking at areas where this will drop. And we have an analysis on the left-hand side. And so what it's telling us is you have a number of areas. It's telling us this, you have some speed drop, but we have a major speed drop between 47,670 and 48. Okay. So what we normally do is you can print this because it's showing you the speed. So when you click print, it's going to show you how your speed profile is dropping. Okay. So we have speed profile. I normally call this A. And the one in the reverse is called B. So it's showing us that one, what you're having is you're going to have some speed profile drops, okay, in this section. So these are the chain edges where you have 35 plus this, there's a huge drop here, and there's another huge drop here, and another one. And then there's one now I do in the reverse direction. So I click right, and then I click next. And then it's going to analyze and tell me, oh, there's a huge drop we're having here. And when I click print, so I'm going to name this B. Okay, so on B, we have a very huge drop here, okay, in the reverse direction. Okay, that's around something around 50 something. So around 56 to this. Okay, there's around, it's saying something along the lines of 6 kilometers. There's a huge lane drop. So if I go back in our profile, I don't have the right styles, but let me try and get the right styles to make this very vivid. Demo speed profile. So click manage, importing the styles. I could do reference. And my main goal here is just to get the styles. So that I can have a good view of what we're talking about. So I'm going to do this. Okay, so we have that, and I want to name this existing ground so that we can see it. Existing ground, and then I want this to have that, to have this. And then I want to add some labels. The labels will make it very easy for us. Table crest, then we do a sag. Okay. So we do have here cases where we're having, let me do even the bands. Let's change the bands. Import band set. This is whatever. So I'm not going to make everything perfect. I'm going to just Okay, so I have a chainage of 50. That's what I'm looking at. I'm like, where's chainage 50? Oh. Okay, where's chainage 50? So we have somewhere around here. So we have 50. In the reverse direction, you know, when you're coming from the start of the road to the end, so we do have a climbing lane that's needed here. We have something 3.5, 2.7, and it's constant. It continues going all the way down, okay, 2 and all that. And it's saying that vehicles are going to struggle to climb in this section here. And this is the section that we're seeing that's roughly around the 6 kilometers. That's what you're getting for the speed profile. Now, of course, if you do a study and you find that maybe the vehicles in this area are powerful, you then have a much less climbing lane. And now all you have to do is go out in your drawing and draw the climbing lanes. Now, drawing the climbing lanes would maybe be for another lesson. The purpose of this was just to show you how you analyze. Otherwise, stay tuned to the channel for more videos. Thanks for watching.